All right, hi everyone. This video is going to walk you through what you need to know to complete your SPSS activity on t-tests. So let's go ahead and first just talk about kind of what we're doing here. So if you look at the assignment, it talks about this data is investigating two groups and whether or not there's differences between these groups in their fear of spiders. So everyone in the group is identified as an arachnophobe or someone who has arachnophobia. So everyone has a fear of spiders. And the idea of this study is to look to see, is there a difference between this fear response when these people are seeing either a picture of a spider or a real spider? So does that evoke different levels of fear? And so these, in this case, 24 participants were split into two random groups, and one of these groups received the treatment of looking at pictures of spiders, and the other group had to interact with real spiders. So we're going to see now how this is different, and they measured the outcome or the dependent variable in two ways. So there's actually two dependent variables here, that being a self-report measure of anxiety and a saliva sample that looked at the level of cortisol, which is a stress hormone, response in that saliva sample. So two different outcome measures, and we're going to look at both of these and see if either is able to detect differences between our two groups. So let me jump into the data here, and we'll take a look now at our data in SPSS and talk about how it's organized and how to go about kind of running this analysis. So the first thing I want to point out is that we have our three variables here along the top, and our first variable is our independent variable, our grouping variable. And notice that it represents either a 0 or a 1 for its value. Now those have been coded, if we look in our variable view, those have been coded with different values. And so a value of 0 represents those in the picture spider group, and a value of 1 represents those in the real spider group. And we can actually view this in our data view by clicking this button up here at the top. Let me see if this button up here at the top, where we can show our value labels. And if I select this and toggle between this option, I can see either the labels or the values that SPSS will use. And both of those are going to be important, and being able to kind of know what each of those are, we'll see here in a second. Then we have our anxiety outcome variable and our cortisol outcome variable as well. So both of these are our two dependent variables, group being our independent variable. So we are manipulating our group, who's in each group, and we're seeing, does that affect the outcome of our dependent variable? Now, there's something we're going to do here before we run our analysis that's a little bit different, is we're actually going to create our graph first, or a type of graph first. The reason we do this is we're actually going to look and see what differences we might expect to find, and that's just going to give us a little bit of an idea of how to interpret the numbers, because we have some expectation already of what we should be looking for. So hopefully that makes it a little bit smoother. So to do this, we're actually going to go first up to the Graphs tab up at the top here, and under this, I'm actually going to look for the one called error bar. So I'm going to first make an error bar graph, and if I click on this, I'm just going to choose simple with summaries for groups of cases as it is here, and click on define. From here, you'll notice that we have our variable and our category axis that show up, and we need to do this for each of our two dependent variables. So we're going to make one graph for our anxiety variable and a separate graph for our cortisol variable. So we're going to go through this process twice. For our first section, we're going to take our grouping variable, and this is going to be our category axis. So we're going to separate our categories by our groups. So we want to see differences between both of the two groups. Then our variable itself, or our dependent measure, our outcome variable, again, we'll select anxiety first and do this one, and then we'll come back again and switch it out for cortisol. So I'm going to go ahead and just leave everything else as it is by default. Notice we're using a 95% confidence interval. We'll talk about that in a second, and hit OK to create my graph. That should create my output, and I should see my graph appear here. Now, before we talk about this, I'm going to go back and do this again for cortisol so we can see both of them at the same time. If I go back to graphs, back to error bar, same things as before, and hit define, I'm back at my graph screen, and I can just take anxiety out and put cortisol in and kind of swap those two. Now, if I hit OK again, we see I get my graph here for anxiety. You notice this labeled here for anxiety. And we get our graph down here, which is labeled for our cortisol. All right, so let's just quickly kind of talk about these two graphs and kind of interpret what's going on here with these error bars. All right, I'm going to zoom in first here on the anxiety graph, and I want you to notice kind of how this is set up. So we have anxiety on the left or on the vertical side, and then we have our two groups of our picture group and our real spider group separated out here. These center point dots here are the actual mean values of our groups. So if you added up all of the averages or all of the values and found an average, that is the dot that you would get. However, we also have these error bars, which provide a range of responses that we might expect to find if we were to rerun this study over and over again. So I always like to say if we run this study again, it's very unlikely we're going to get the exact same mean value, right? That's going to fluctuate slightly over time, and we expect that it's going to fluctuate anywhere within these ranges 95% of the time when we rerun this. Again, that's our 95% confidence interval that we see here. So 95% of the time, we expect these mean values to fall somewhere within these ranges. Now, why is that important, and what does that mean for interpreting this graph? Well, if we look at these values and we say we're trying to compare these two groups and we want to know which one has higher or lower anxiety compared to the other one. Well, if we ignored the error bars and looked first just at the mean values themselves, well, it would appear that the real spider group had a higher value and the picture spider group had a lower value. However, we have to take into account these error bars because they tell a little bit of a different story. So if we use this 95% confidence interval, we can expect that this mean value is going to fluctuate within this range. So sometimes it might be down here, sometimes it might be up here. Same thing over here. Sometimes we might get a value here or up here. And so let's say we reran this study and the two values that we ended up with were, let's say our mean value ended up right here and our mean value ended up right here. Well, now if we compare these two groups, we see something else. We actually see that it appears that the picture spider group had a higher average and the real spider group had a lower average. So since these have now flipped, well, what does that mean? Well, it means that we can't confidently say that one or the other is going to have a higher value every time within that 95% confidence interval. So because we can't say for certain that one is always going to be higher than the other, we would mark this as not significant. And actually, this is going to be what we're looking for when we run our analysis for our p-values. So we interpret this or we expect this to not be significant. There to not be a significant difference between our two groups as measured on the self-report anxiety. Let's look at cortisol next and see if this kind of tells a different story. So if we instead now look at cortisol, again, so now we've switched and we're looking at our cortisol graph here, we see something a little bit different going on. We still have our two groups and we still have those mean values within those ranges, but notice what those ranges are. They are much smaller and there is a distinct difference between the two of them. So what I mean by this is that no matter where within this range these values fall, even if this was as high as it could be and this one was as low as it could be, no matter what, there's always going to be the real spider group having higher values and the picture spider group having lower values. So it doesn't matter where the mean value falls within that range, it's always going to be higher for the real spider group. And so because of this, because we can confidently say that the real spider group is going to have higher average values of cortisol 95% of the time, then we would mark this, well, yes, this is going to be significant. We're going to expect to see that significance when we look at our results. So let's go ahead and do just that. Let's run next what we're going to call a t-test, which is how we compare two group mean averages. And we're going to see if what we find aligns with our expectations based on our error bar graphs. So to do this, we're going to go up to Analyze. And from here, now we're looking for something a little bit different. So we've been working in the correlation table section, but this time we're going to look for actually compare means and proportions. And this should make sense because what are we doing? Well, we're comparing the mean value of our two groups, both in anxiety and cortisol. So we're going to look for compare means and proportions, and you'll notice a bunch of t-tests start appearing, so that tells us we're probably in the right place. And the one that we are looking for here is actually an independent samples t-test. This is independent samples because we have two separate groups of participants. So we have participants in group 0, or the picture spider group, and we have participants in group 1, the real spider group, but they're separate from each other. So we have independent samples t-test. So we'll go ahead and select that, and notice again we have our dialog box showing up here with our variables on the left and places for them to go over on the right. So let's start off actually with our grouping variable, which is simply going to be our group. So we're going to take our group here, and we're going to move it over into our grouping variable section right here. Next, our test variables. Well, those are our dependent variables, and we can actually include more than one here at a time. And what this is going to do is run separate t-tests for each of our variables. So it's not one analysis that includes both. They are separate analyses for each of our dependent variables. It's just going to run them both at the same time. So we could just do one at a time and come back and do this all again for the second one, but at least for this, we can put them both in, and it allows us to just run them both once. Now notice, with all of these in, it doesn't let me select OK. So I actually can't push this button and run this test yet. And the reason for this is that I have to define what my groups are. So one unique thing about a t-test design is that it can only measure differences between two groups, no more, no less. So what that means is, while yes, we only in this case have two groups in our data, 0 and 1, it doesn't know that. So we might have extra data in our data table that includes groups from, say, group 2. Maybe that was a toy spider, or group 3 that was some other type of independent variable. So we need to define or tell SPSS which levels of this variable we want to run in this analysis. So if I go back over to my grouping variable here, I can define my groups, and by default it has group 1 and group 2, but that's not the values that I'm using in my data. For me, I have 0 and 1. So I need to say group 1 is going to be everybody with a value of 0 for this variable, and group 2 is going to be everybody with a value of 1 for this variable. And so once I've put those two in and hit continue, notice now that I can run my analysis. It allows me to select this. So I could go ahead and hit OK, but before I do that, I'm just going to go quickly up to options and just check this, and notice again that we are in a 95% confidence interval and everything looks good. So I'm going to hit continue, and now I can hit OK and run this analysis. All right, from here we get 3 different graphs, or 3 different tables, I should say, and they each tell us something a little bit different. The first one here is just our descriptive statistics. These are going to be useful to identify our mean and standard deviation of our different groups. Notice within this table, let me just kind of make this a little bit bigger. Notice within this table, they are separated out by our anxiety dependent variable and our cortisol dependent variable. So if we look at these mean values here, we have our mean value, or the average anxiety for everyone in the picture spider group, and then our average anxiety for everyone in the real spider group. Same thing again for our cortisol level, but these are values, are the level of cortisol between our two groups and the level of anxiety between our two groups. So that's what those are. Those are just our descriptive statistics. Those will be important in reporting and understanding kind of just what those groups' averages were. The next table is really the most important table, and this is our actual t-test output. So this is going to tell us what we found and was there a difference between our groups. Notice again that we have one section for anxiety and one section for cortisol. So each of these are 2 different tests. Within each of these tests, there are 2 lines that we can interpret, those being either equal variances assumed or equal variances not assumed. And so for us, right now in this class and on this assignment, you can just focus on the line where equal variances are assumed. So that top line for both of our variables. So for us, if we go through, we can now find different information about this t-test, such as the actual t-value, our degrees of freedom, and then our significance broken both into a one-sided and two-sided p-value. Again, for us here, let's go ahead and stick with two-sided p-values. So we'll use these values here for our significance, and then it gives us some other information like our confidence interval, our difference, and standard error. But again, the main things to focus on are going to be this information of the t-test for anxiety and these values on the t-test for cortisol. And so from those, you can interpret those t-values and the p-values to identify whether or not you had a significant difference between your groups. And if we look real quickly, we can see the p-value for anxiety is going to indicate that we did not have a significant difference between our two groups. Our p-value is greater than 0.05, which is that cutoff we use. However, for cortisol, we see that we do have a significant difference because that p-value is less than 0.05. It's even smaller. It's actually less than 0.001. And so we can use that to answer the questions. And this also aligns with our graphs where we saw a significant difference in cortisol, but not a significant difference in anxiety. This last table here will tell you your effect sizes. For these, you should be using Cohen's d and the point estimate. That's only really for reporting, which you might have to report for the very last question. And you would just look at that negative 0.686 and the negative 2.907. Those would be the only values you need to assess in this table, and that is only to report them as your effect size in the very last question. All right, hopefully that gave you a solid understanding of how to go through this assignment. You'll go ahead and complete this assignment, answering the questions and reporting the values that you find. If you have questions, always feel free to reach out, and hopefully this goes well for you.